Good morning, everyone. Good morning, everyone. Everyone again. Third time. Okay, sorry for this. Okay, so I hope the first day was awesome. The second day is going to be also awesome. And we are starting with a very interesting topic about GraphQL. Radoslav will tell everything about that. Also, don't forget about our bots. You can rate and ask the questions during the talk, so we can, after the talk, if we have time, we can then answer these questions. And don't forget to give feedback to us, to the speakers. That means a lot to us. And of course, enjoy. That's it. Thank you.
Okay, hello. Hi, I'm Radoslav Stankov. I come from Bulgaria. A bit of more technical note. All the slides are already on speaker deck. So, and all the slides links are also there. So if you later want to see the talk again and like see some of the links, don't feel that you have to do something like this during the talk. Like pretty much we are going to have all the slides are already here, and this will be my last slide from the presentation. So if you decide you like it, you can check it out on speaker deck. So let's go to the main subject. So yeah, I worked at a company called Product Hunt, and we developed this web application which started as a single website, like a very typical website, and right now it's like a single page app which is run by GraphQL. And today I'm going to share with you how we approach GraphQL and how we deal with it in Product Hunt, what benefits we get, some of the challenges we had, and all about that. So that's my goal for today, and hopefully I'm able to fulfill this promise. So context is king. So the way Product Hunt works is we are hosted on Heroku, and in Heroku there is this concept of dynos. You can think about them as containers or servers, and on each dyno we run three things: an Nginx, Ruby on Rails GraphQL server, which is used for a GraphQL API, and a Node.js app, which is used for server-side rendering and displaying like the content for Google or for slower mobile phones. So the way stuff works is when a browser comes with a request, I want the full page, then Nginx proxies this request to the Node.js server-side rendering script, which on his part calls the Rails server with the GraphQL API. When the page is already loaded and people start clicking around, the Node.js proxies all calls to a GraphQL APIs to the Rails itself. And basically for the client, this is like a black box, or like it works in synergy together. And today I'm mostly going to focus about our front-end stuff, because on the back end there is a lot of like good tools in the Ruby community, and in the front end there is a lot of questions: how do I work with GraphQL? But first, how actually GraphQL works. So the best way to explain GraphQL is usually by example. You just show a use case, how we can build something with it. So this is like a Product Hunt page right now. This is one of our pages, and let's, during this presentation, I'm going to show how this page actually works internally. But since I have only like 40 minutes, I'm just going to simplify the page, so I'm going to build only this part of the page, and but it's going to show you like pretty much how we use GraphQL. So usually when you have to build stuff, it's good to approach the problem from the point of small pieces, small incremental steps. So in our case, it's best to just think about how would we render just this item here. Like this is a line item in our domain, it's called topic. And what data do we need to render this React component? What's the data required for that? So if I have to think about it, a topic needs an ID, because everything needs an ID to be identified. We need a topic name so we can display it. We need a description for the topic so the user can actually know what this topic about. We have an image for the topic because people like images and GIFs. And we need a status to know if the currently logged user actually follows this topic or doesn't. So we can show the follow button with different states. So how do we get this data from the server? Like GraphQL is a query language. It's not like a database. So the way we get this data in a GraphQL query is by just adding this to the code. We just say, okay, this is a query. Query fetches data. I need a topic with ID 1, and all the rest is pretty much the same. So if we see it before, like we have that, this is the data we needed, and this is the GraphQL query. So you can think of GraphQL as a JSON template. You give it a template like this, where you give this template, okay, this is the data I want, this is the shape I need. The server does some voodoo magic or whatever we want to call it, and it spills out a JSON which follows pretty much the same structure. You can see it has everything, all the data in the same format. So this is basically what GraphQL is. You have a single endpoint and you send us a query, like a text, a JSON template, and Java, and the GraphQL servers fill out this template, fill up the blanks. So let's go back to our current item. Okay, now we have the data. How we should proceed with this data? How we are going to have it, like for example, with React, because in ProHunt we use React. So this is how our component is going to look like built with React. We have a topic item component, and inside this topic item component we have a topic image which gets a topic. We have a title, the description, and we have a topic follow button. And this is simple enough, but looking from this code, like I'm seeing this code and I'm seeing what data it has, and I'm wondering, okay, is this component topic image, what kind of data does this component need for itself? Does it need the image, or does it need the name for the alt text? Does it need the ID for something? In the topic follow button, do we need, is followed like it's obviously needed, but do we need an image or a description or a name? Like looking at this code and the data we need, we actually don't know what kind of the data is needed where. So in GraphQL you have this concept of fragments, which is one of the most innovative features there. The fragments, you can think about them like the new ECMAScript, whatever here is now a spread operator. And what it basically does is you can split your data into chunks like this, and every chunk of data gets compiled into the same query when you make the query itself. Like right now this looks kind of messy, it's scary, but let's look at point by point. For example, the topic image. The topic image has this fragment which is called topic image with this surprisingly name. And you see now that the topic image component only needs an image. It doesn't need anything else to be rendered. That's cool. The topic follow button actually surprisingly needs the topic name for some reason. I don't know why, but I don't care. I'm just a user of this component. It needs the isFollowed, obviously, and it needs the ID. But the topic item itself needs the ID. It needs the name and description, and it's obviously why it needs the topic and the description, and then it needs the components for the topic follow button and the topic image button. So what basically happens here is our topic item fragment doesn't know what the other fragments have during you as a developer when you write that, but it collects all the data. In this way, when you develop a component, you only need to know what's the immediate data this component needs and what other components this component renders, which is obvious because you see it in the same file. You don't need to jump and guess. And like you see the surprise, like the follow button needed the name. And who would guess that you need the name for a follow button? And then you make your own query when you say, okay, I want to get the topic with this ID, and I need enough data to render a topic item. Now, we actually don't know what the topic item contains, and when we develop stuff, all this trickles down together. And the funny thing is, when you execute the query, it actually returns the same JSON. Like, this big bulky thing goes to the server compiles it. Like, you can notice that name and name, like we have the name loaded twice. Of course, we don't get two names, we get one name. It's smart enough. So now, with this simple query, when we are building, we have, okay, now we get one item. And this is our first step. Like, we have one item, and one item is useful, but not enough. Let's see how we are going to render a list of all items. Like right now, if I had to build this, if I have to write all the data it's needed, and I have this as a design, I have to like dig into the code of every component and say, okay, where is this, where this come from, and compile. And the problem is you can do this while developing, it's quite easy, but when you change stuff, how do you know? So basically the code for fetching this is you just say, I need all topics, and I need to render them in a topic item. I need the data for a topic item. And GraphQL is smart enough to know that all topics returns an array. And this array contains only the data you need. If in some point, for example, the image needs a property called alternative image or a default image, you can just add it and the whole query will trickle down. And that's very powerful. So this is how GraphQL basically works, but how do we connect, actually how do we get this data? So in Product Hunt we use this open source library called Apollo, which is a client for GraphQL. And the next part of the presentation I'll actually show you how we are using that. So before that, this is how we structure our GraphQL and React files. So we use this pattern in React which is called the folder pattern, where each of your components gets its own folder, and every folder has a couple of things. It has an index, which is the component itself. It has styles, which is what these components looks like. Because we use CSS module, all the styles are localized to a single thing. And we have the GraphQL fragment. So with GraphQL fragment, we actually express what data this component needs to be rendered on the screen. And having those components in packages, we can add additional files like utility functions, subcomponents, and all that nice stuff. And this is how we organize. So the fragment GraphQL file is written by Apollo, and those files look like that. Like here, like during the presentation, here is where the files are, like in the structure. So this is how the topic image fragment looks like. And it's pretty much the fragment we have. And this component doesn't know how it's used. It only knows that it needs an image from topic. If we see the fragment for the topic follow button, again, it's the same fragment we have. Because like if you write the queries by hand, it will be like kind of like hard to like keep track of them. So the other nice thing about the GraphQL files is, for example, this is the fragment for topic items. In the GraphQL files, you can actually import other fragments. And when you import the other fragments, you actually get them. And you actually don't care what the fields they have. They just trickle down together. And in the end, the other thing we do at Product Hunt is we actually split our components into two things. One is called components, which keeps components which are generally reusable between different pages. I personally like to call them foundational components. My colleagues hate to call them foundational components. And the other type of components we have are called pages, which represents, surprisingly, pages. So the pages component have a query. The query is what actually gets the data. This is like, in the end, this is how a query file looks like. It's a normal GraphQL file, but it doesn't know what the topic item actually have. It just gets its data and renders it on the screen. If you think about it like charts, the topic page has the query, and this query only knows that the topic page have topic items. It doesn't know that the topic item have an image or a topic follow button. So if I have to do a redesign, like we do very often, if my topic item doesn't need to have an image, I just remove the component in its fragment, and the whole query fetches the minimum amount of data needed. If, for example, the topic item needs, for example, the followers count. If we want to have a follow button which shows you how many people follow stuff, I just change this component, the topic follow button, and then this whole chain gets the field, and it doesn't care why this field is needed. So this is how structured it looks, and this is how it looks in code. So this is the code of the topic page. Topics index page, sorry. So what we have here is a topic item. Using Apple, we can actually import the query from the page, and you need this decorator from React Apple. So what you basically do is using this high-order component, you have your content here, there is some stuff here, then you use this high-order component the same way you would do something like Redux. You give it a query, and then you wrap the whole query, and this query gets props. So this is how GraphQL queries are made to the server. The content component itself gets a property which is called data, which contains all the relevant information from Apollo. This information contains a couple of things. The two most important are, first, you have all topics, which is the data you actually required. So you can actually get all the topics and just render them for the topic item. This is what you need. But the thing about it is, you are loading this data. It's not, unfortunately, it's not instantaneous. So you need to have this check here to check if the query is currently loading, can show a spinner or some cute cat animation or something like that. And in this data, there is a lot more other properties which you can use, but pretty much all your queries, most of the pages would look like that. The thing about it is, and this is like one of the first lessons we learned, was there was a lot of repetition. Like Apple is a very young library, and it doesn't have a lot of primitives, and also our applications are very different. So pretty much all our pages look like that and had this nast if every time. And people sometimes forget to add it. And what we did is, okay, we wanted to change the loading animation, and then we decided, and then was like, oh wow, we have to change like 20 pages to change the loading animation. Let's not change the loading animation. And then we extracted this high-order component. We have a folder called decorators where we have our high-order components, and we extracted a high-order component called with loading, which pretty much is this check, but it's in a single place. So if you want, so now you can pretty much cannot forget it. It's very easy to add, and we can always change what the loading animation looks like. And we do this nice dance of chaining high-order components. And since we're using a lot of high-order components, chaining them like that is a bit trickier, because I'm like, okay, which is which is the argument, which is the second argument, what's the order, and all that. So Apple actually has a very interesting utility function called compose, where you can just give it a list of high-order components, and they will be applied in that order, and then you can order them in a component, and then in the end, you get one high-order component for your content. A lot of other libraries has this utility. We have our own, but right now we are moving more and more to the compose from GraphQL. And now, when you look the code, it actually makes a lot of sense. You say, I have a query, this query have a loading, and it renders content. It's very readable. And that's how you get this component. But looking at this code is one thing which some people would notice is we don't have prop types. We don't have any like validations for the attributes. Like the query can return whatever, and we don't have any safety. So we are using for quite a while now a library from Facebook called Flow. And Flow is like a static type analyzer with optional type system for JavaScript. It basically gives you some extra syntax like this. You can define your own types, which are just shapes. They're not like classes. You cannot say new topic. You say something has this shape. And flow type actually can save you from a lot of frustrations. Like it adds a bit of extra syntax. So here is following, I give it a user and give it a topic, and I do some checks. And if I pass some data which is wrong, it will blow up on compile time. And this won't even hit my production, never. And the other nice thing about Flow is it has the concept of nullables or maybe types, where you have to explicitly say that the value can be null. For example, here I say the user is current user, and if I pass null, it will blow up because null is not a current user. I can say a value is either current user or null, and this would work. So the nice thing about it is combining a couple of tools, like chaining them together, you can actually define a flow types based on your GraphQL schema. Since on the server, when you define GraphQL, it's strongly typed. It has a schema file, you define the whole schema, and every type has certain fields which takes for certain arguments, and you can also say, yeah, the user always has an email, or this user maybe have an email, maybe not. And we used the Ruby gem, so there is this Ray command where we build it. We have a JSON file which contains the description what our schema is. Then Apollo has this other tool which is called Apollo Code Gen, where we give it our current schema file, we give it a selector to find all the GraphQL files in our system, and it builds a couple of helper files. First, it validates that our queries can be executed on the server. For example, if I decide to change the topic name to topic title, this command here will blow up because the query says, okay, you don't have a name for a topic anymore. And we can change that. And this is a very nice way to make sure that your API calls at least have a chance and they have the same shape. The other thing it generates is with this flag target flow, it generates a flow types. So here in my content, I can add a couple of type annotations and say, okay, having this comment here enables flow for the certain file. Flow is enabled on file basis, which is cool because my tests don't need to be type safe because their job is to be safe. But here I can import a type, and the type is like the topics page query from this schema file. And I can say in my properties that the data I get is topic page query. I get it here. And from now on, GraphQL actually knows that I get that the data has all topics. All topics is an array which contains topic items kind of data. And for example, if I change, if here I write, I want to request something else, let's say all users. While I am compiling my JavaScript, it will blow up and I would know that I have made a mistake. The nice thing is this thing, again, as GraphQL trickles down, so the topic item has also its own type annotation. So here you say that the topic item expects the topic item fragment to be passed into a topic property. So having that, passing that here would, if you don't pass a good enough data, it will blow up again. So you have this very nice way of make sure that if my code compiles, I have some kind of certainty that stuff works. And it's also really good for refactoring, and with flow type you also have good type support. The same is true for TypeScript. Like this is always the question, why flow, not TypeScript? In our case, it's historical reasons. But the same thing which I said about flow is totally true for TypeScript as well. So cool. Now we have our list, we have our stuff, we are type safe, we are feeling like engineers, and we are happy about our lives, hopefully. So Now, another thing I want to share with you is GraphQL is cool, but it's a free format. Like, you can design your GraphQL schema however you want. You don't need to, like, you can pretty much shoot yourself in the foot by designing a very bad schema. A schema having performance problems, a schema having other issues. And right now there isn't much guidance how you design your schema. And what we found out was when we started using GraphQL, we wanted to have like best practices. And the only one who was using GraphQL and sharing their best practices except Shopify and GitHub were Facebook. And Facebook had this library which is alternative to Apple called Relay. And Relay is actually two things. It's a library which is comparable to Apple, and they have a schema definition. They have the GraphQL Relay specification. That means they give you some guidelines how you should design your schema to be compatible with their library. Like, we decided not to use Relay back then, but we say, okay, maybe in the future we might use Relay, who knows, like, I don't know. And that's the reason we design our schema to be compatible with Relay schema. So Relay schema is just like a specification. Here is the URL, it's in the speaker deck. And Relay specification has only like 3 fields. The first, it has 3 properties. The first one is called the node ID. The node ID is a very simple concept. The idea here is, right now my ID is 1, and I can have multiple items who have the same ID. And I cannot uniquely identify a topic by its ID. But if I say that the ID of my topic is actually the base64 because we want to look cool, plus the topic /ID, this becomes like a unique identifier in my system. So having this unique identifier node can give me an ability to just have like these raw-looking IDs. And using those IDs, you can request every object in your system by just using this node query, where you just say, okay, give me a node, and this node have this ID, and I need to be a topic. And if this node I get is a topic, I need its name. If it's a user, I need its full name. So having this node interface helps you very much with caching. Like, this is the best way to cache data and put it in and out of the cache. Relay uses it extensively internally. There is some security consideration with the node interface, because if every object in your system is accessible by a single query by an ID, you have to add the protections to check if the user can actually have access to that field. But this is something you do only in one place. So the other thing which is more important, like connections, like nodes IDs are cool if you use Relay, but the other thing which is, I think, really cool, it's called connections, and this is how you do pagination, in GraphQL. Since GraphQL, in theory, has to be a graph, and the graph has nodes which are connected, so they have this connection specification. So right now I have this query with all topics, which I get a topic item, but if I have 50 items, it's okay. But what if I have 1 million topics, 2 million topics, 20 million topics? I have to have a way to segment them. And the way to segment those is to add, to make this have this structure. It looks intimidating in first, but let's see how it actually works. So right now you have the first 10 topics after a certain cursor. The cursor can be an ID. If you have your items sorted by ID for an infinite scrolling, the cursor can actually be a page number. You can say, okay, I split stuff into pages. It's very flexible, but you have this interface, so you can have, okay, from this cursor, give me the first 10, the next 10, the next 10, the next 10. You have edges with nodes where you have the data you actually need, and you have this payload object called page_info, where you have information about your pagination. Because one problem with REST was, where do I put how many items I have totally in my pages? And in GraphQL, you can in this connection stuff, you just have the page info, and you can add quite interesting stuff there. Also, the other nice thing is this should be able to work backwards. So you can say, okay, I load the first 10. Now I want to load the previous 10. So imagine when Facebook building it, they just have like an infinite feed, and you load your device, you have the feed, you start in the middle, then you move up, so you load the last from the previous one. And that's pretty much what the specification is. You have a connection name, you have the argument first after, you have the edges, which inside you hold the cursor for each edge, you have the node, you have the page info, and that's pretty much the whole structure. So, like, this is our page right now, and using the Node API, we actually can have this type of behavior, like a very cool infinite scrolling. So let's see how we do the infinite scrolling. So this was our previous query, where we say, okay, we load all items, and now if we have 1 million topics, the user browser spins forever. But now, transforming this into connection becomes like, okay, give me the first 10 topics. Again, I need the topic item, I need the page info, I have my float type, so I actually know I'm type safe, and I'm very happy about it. And my page, this nice looking page becomes, I just need to add this old topic and have this extraction. And this is a code smell because if you notice, this is quite long, and if every time I have to type it, yeah, I have float type, it's type safe, I have autocomplete, it's cool, but imagine having specifications, so that means every connection has the same shape. So we have built on during the time we use GraphQL a lot of utilities like this one, which is called extract edge nodes. And this thing, what it does is just extract this piece, what an edge is. So if sometimes Facebook decides to change what a connection specification is, or we want to break their specifications and have our own plugin, we have a single function which handles all of that for us. And of course, this is JavaScript. Even with float types, you add some protections just to make sure it works, because this is like a core utility, and you want your core utility to be very stable. So having this utility function, we just add it here. It's nice. It's so nice that you can actually inline it, and our code looks even better. And that's cool. That's really nice. But right now, I'm loading only the first 10 items. Again, we're doing baby steps. I'm loading the first 10 items. How do I load the rest? I have to add a cursor. I have to say, okay, have a cursor, which I load stuff afterwards. Have a page info, and the page info needs to have the end cursor, and does it has a next page, because you want to stop infinite scrolling at some point. So how do we implement this? So this is our nice, beautiful page. It's really cool. It's small. You don't have many duplications, much duplication actually. And this is how it looks when you write it with having the edges. So here, now that the data topic has next page, we have our own custom infinite scrolling component. Like, it's very custom to our needs, but I guess you would have at your application something similar, where you say on scroll, execute this load more function, which comes from somewhere. Has this next page, checks, okay, am I having more pages to load? This component is like smart enough to like load stuff, unload stuff, and that doesn't look so bad. But where is this load more coming from? So load more comes from this other GraphQL query. So the nice thing here is, when you are using the GraphQL header components, you can actually extend some of the functionality. So you have this nice looking thing where you have a lot more with some, I mean, it's very chaotic code. It's especially now in the mornings after a dinner and speaker's dinner and so on. It's kind of hard to explain, and when you see that and you have to say to a colleague, yeah, every page we have infinite scrolling, which in our case like 40, 50 pages, you have to write this code there like that, and I'm like, this is pretty much how we would look like when I had told this to my colleagues. Is really, you have to do that? They said some words which are not very good to be spoken in camera. Like this is one of the approaches right now with Apollo, is that Apollo is a bit like shopping in IKEA. You get some pieces and you have to combine them yourself. Like even Apple acknowledged that with their new version, Apple Link is a lot more modular and actually helps you to have the mindset that you have to build up a lot of specific to your use case components and abstractions, which first makes you a better developer because you build your own abstractions, and second makes your life easier. And I mean, I like to have an easier life. So let's approach this function here. We have our code here, and let's abstract it. Like we are developers, let's move it up. What I like to do is just highlight what's the difference. Like if I have to write this like 30 times, what will be different in this code? And this will be the different parts. This is like what's different about all pages. You have to pass a data with some function, and you have these all topics. So that's cool. So the difference is data and some path, which is the connection I have to load. Okay, that's cool. Let's extract it. Let's have something like load more, which has path, and it gets the data. And this bottom part actually is the same across all infinite callings we have. So I can actually have a function, which is a function builder, which just gets a data and a path, and it gets me this load more function. And that's cool. Like I have it, and I just have that. So my code looks like this, and I'm like happy. I'm really happy. That's cool. Like that's a good abstraction. It helps you. Everybody knows how it's doing, and also if you connect to flow type, you have type safety and all that good things, and that's cool. But then, if you look at, and that's like a good win. It's nice, but we shouldn't stop there. We should look at the code, and we see that okay, load more. Like the only reason I need load more is to pass this load more to infinite scrolling. I'm not using it everywhere else. And then you start to think and get some substances like coffee and other stuff. And you think about it, why do I need load more? Why load more is not part of the infinite scrolling component? So in the end, you can just put it in the infinite scrolling component, and you just give the infinite scrolling components the arguments of load more. It encapsulates the whole connection, it encapsulates everything. So every time you need infinite scrolling, you just give it a data, you did a connection, and then you are happy because your component adding infinite scrolling actually didn't add that much code to your application. Now you have something reusable, and you are happy. And this is like pretty much the approach you should take with GraphQL. And when you approach stuff like that, think about how you build abstractions to make your life easier. And yeah, some of those things can be open source, but most of our stuff is very specific to our applications, and they have a lot of emojis and cats inside of it, which some people like dogs and stuff like that. So that's how we do it. But in GraphQL, it's good for like fetching data. Good is like a small word. It's great, but sometimes we need to like mutate data. We need to like change the data, because if we don't change the data, okay, we can cache everything and we don't need to worry about stuff. So GraphQL has the concept of mutations. And actually that's the third thing from Relay, the mutation specification. So this is our topic item, which we already seen a lot during this presentation. And let's see how we implement something like the topic follow button. So the topic follow button will make a mutation query. This is how you make a mutation query with GraphQL. You make a mutation which looks kind of similar to a RPC call, and you pass it the topic ID, and afterwards you fetch some data. Does it follow state changed? And this is how the follow looks. This is how the unfollow looks, and this is the way you change data. And this is cool, this is nice, it's simple, and what Relay adds to the specification is, let's imagine we have a mutation which takes multiple arguments, like this type of multiple arguments, like ID, A, B, C, and some other stuff. Every time I add a new argument, I have to change my whole query, I have to change like 5 files, and all that. So what Relay says you should do is, you have an argument which is called input, which is a special type which has a map of all the data you need. You should have something called client mutation ID, which is only used in the Relay library internally. We don't use it, but we follow it just because it's easy, because you always return 0 in our case. And then you return, and then you can actually query the data you need here. So for example, here I'm querying a topic, I can query a user and all the other stuff after the data is mutated. And this is how the mutation will return. In our case, we always return 0, and that's cool. Oh, thank you. Here, so yeah, we get this input, and then we get this client ID. And this is how our component looks like. This is how the topic follow button looks like. This is its mutation files. The mutation files look pretty much the same way they would look. The query files, we just change the mutation with query. And this is how it's going to be executed. So here, again, we are getting the query. We have this function which is called follow topic, which has some variables, which is this input variables. Also, we have support for optimistic responses. That's the idea. When the user clicks follow, they want the button to become red because they want to follow. They don't care if what server returns and gets some. That's our job. And 99.999%, the server should return the correct thing. So you give it an optimistic response, which is when you click, it instantly returns that, and afterwards, it just refetches the data and it's replaced afterwards. And the button itself, you just check if it's a follow button. You have some code here where you say on click, do a follow, then you do unfollow. And again, this works. This is how the mutation is going to look like. I do a follow topic. It changes from true to false. Then I do the follow and I get oh. And that's cool. But one thing we do at Product Hunt is we rename this topic to note because GraphQL uses note a lot in its text. So we have this note. All our mutations actually return something called note, and the note is the thing which was mutated. And we always call it note because we build tools on the server side and in the front end to actually know that the mutation always gets note, so it actually talks to each other in a very simple way. So we don't need to think about it. Was this mutation for topic? Was this mutation for user? Was this mutation for whatever? The final part of my presentation is how we deal with forms. We are developers and we live happy until somebody tells us, yeah, you should implement a form. And then we become very unhappy. And we have this simple form, a very simple form. And implementing form with GraphQL is quite simple. We just have this mutation. It gets all the input, and we can gather this input, just store it in a JavaScript object, pipe it here. And then the note is the settings, the user settings. We store stuff in the fragment, so when the user updates their settings, automatically all the settings are changed across the whole front end. And that's cool, that's cool. This is how it's going to look like. In our case, we have a settings form, we have the fields, we have a mutation, and then we just get all the variables which come to the submit function, and that's cool, that's nice. We have some other helpers like on submit and other stuff, but then we have to think about validation. And client-side validation is cool until somebody bypasses it. And what we do here is how do we handle errors? So this is how the form looks like. Where do you put the errors? The way we do it is we have an extra errors field, which we have errors which are mapped from a name to an array of errors. And this is like an extension we do. All our mutation has this form. They have these errors, and this is a very nice way because we connect them to our form helper. So automatically, when our form helpers know they work with GraphQL, they can map errors to fields. So yeah, that's pretty much what I covered today. I told you about what GraphQL is, what Apollo is, the relay specification, show some example with data fetching, pagination, mutations, forms. And yeah, we are close to an end. So I don't know if this room has to clap or something, or just tap on the earphones, no idea. Yeah. So yeah, thank you. And as again, all the slides are at this address. You can check them if I was a bit quick in the end. Thanks.
Thank you. Unfortunately, there is no time for the questions, but of course you can ask him.
Yeah, I mean, I'll be walking around.
Yes. Thank you. Thank you.
See ya.